Appendix problem 3.14. In banking of road, we have not included the friction exerted by the road on the car. Suppose the coefficient of static friction between the car, tyre and the surface of the road is mu s. Calculate the minimum speed with which the car can take a safe turn. So in banking of road, we have studied the banking of road in the theory. There we didn't include the friction force. Okay, now we are including the frictional force between the tire and the surface of the road. Okay, so here when the car is taking a safe turn, okay, in the banked road, there are three forces are acting. Okay, what are the three forces acting here is, one is the gravitational force. Okay, so the gravitational force mg is acting, and it is acting what? Downwards. Okay, and the other force is the normal force. So this is your normal force, N, acting perpendicular to the surface of road. And the third force acting here is, this is the third force, that is the static frictional force. F, acting on the car along the surface. Okay, now I am going to resolve this normal component into, that is the normal force, into its components. Okay, so when I will resolve its normal components, so I will be getting here, this is n sin theta and this is n cos theta. Okay, similarly I can resolve this frictional force into two components. Here this is f sin theta and this is f cos theta. Here this is same. Okay, now the centripetal force, because when the car is taking a turn in the curve, it possesses centripetal force. So the centripetal force is exerted by horizontal component of these two forces, that is normal force and static force. Okay, so we can write n sin theta plus f cos theta. These two forces are providing the centripetal force, so it is mv square by r. Okay, now we'll come to the vertical direction. In vertical direction, no acceleration. So the forces acting will be equal. So n cos theta is equal to, here two forces are acting, that is f sin theta and mg. So it is f sin theta plus mg. So we can write here, it is n cos theta is minus f sin theta is equal to mg. Now this I am taking it as equation 1 and this I am taking it as equation 2. Okay. Now 1 divided by 2. So I can write n sin theta plus f cos theta by n cos theta minus f sin theta is equal to mv square by r by mg. So this and this will get cancelled. We will get it as v square by rg. Okay. Now to find maximum speed for f, I am using mu s n. Okay. So I can write the equation as n sin theta. For f I am writing it as mu s n cos theta by n cos theta minus mu s n sin theta, which is equal to, for V I am writing it as V maximum by Rg. Okay. Now here I am going to take n cos theta outside. So if I take n cos theta outside from this equation, here it is n sin theta by n cos theta plus mu s. Okay. Here also I am taking n cos theta outside. So it is 1 minus mu s into n sin theta by n cos theta, which is equal to V maximum square by Rg. So n sin theta, this one get cancelled. This is tan theta plus mu s divided by 1 minus mu s tan theta. It's equal to V maximum square by Rg. So we have to find out the maximum square. So what is V maximum is equal to, square is equal to Rg into tan theta plus mu s by 1 minus mu s tan theta. So V maximum is equal to root of Rg into tan theta plus mu s by 1 minus mu s tan theta. Suppose mu s is equal to 0. Okay, then we can write, then we'll have a safe speed. When we neglect the friction, we'll have a safe speed. Then so V safe is equal to, if you put 0 here, this will become 0, this will become 0. So it will be root of Rg tan theta. Okay. Suppose the car turns with speed V less than V safe. Okay. Then the static friction will act upon the slope to prevent inward skidding. Okay. Static friction will prevent inward skidding. Okay. If V is greater than V safe, here also what is? The static friction acts down. Here it is acts up. Here it will acts down to prevent outward skidding. Okay. So for a safe turn, you should have this value. For a safe turn, you should have this value.